Hello class and welcome to Unit 9 Video 1, Multiplying and Dividing Rational Expressions. Your learning targets for today are that you can simplify rational expressions and you can simplify complex fractions. Okay, so rational expressions are things that are made of ratios. So today we're going to be looking at fractions and then we're looking at complex fractions, which means fractions inside of fractions. Sounds bad, but it's really not. So we're going to be looking at fractions today and simplifying them. The first example we look at is the Goody Shop sells candy and nuts by the pound. One item is a mixture with 8 pounds of peanuts and 5 pounds of cashier. So they say, therefore, 8 over 8 plus 5, or 8 over 13, of the mixture is peanuts. Okay, the way that comes about is because if you want to figure out how much of the mixture is peanuts, okay, you would take your peanuts over your total. Okay, so currently there's 8 pounds of peanuts over the total. The total is 8 plus 5, which is 13. Okay, so what they're saying now is if the store manager adds an additional X pounds of peanuts to the mixture, write a new ratio to show what portion of the mix is peanuts. Okay, well if I'm adding X pounds of peanuts, my peanuts are on the top, so I'm going to add it to the top, but I'm also adding it to the total. Okay, so this is going to be my new ratio, 8 plus X over 13 plus X. This is my rational expression, and we're going to be simplifying rational expressions today. Okay, rational expressions, it's a ratio of two polynomial expressions, which is exactly what we just looked at. So let's just write that down as our example. 8 plus X over 13 plus X. Okay. We're going to be multiplying rational expressions today. So when you multiply, let's just think about something that we've done before. 5 over 6 times 4 over 15. Okay, if I want to multiply this, I could go multiply straight across and then simplify. Or the other thing you could do is you could look at it and be like, okay, 5 and 15, both divisible by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. 4 and 6, both divisible by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. Then we multiply across. 1 times 2 is 2 over 3 times 3, which is 9. Okay, so cancel if you can, and then multiply across. Then we're going to be dividing rational expressions. Okay, well if we're dividing, all you need to do is multiply by the reciprocal. So flip the bottom fraction and then multiply. So for instance, if I have 3 over 7 divided by 9 over 14. Okay, well if I am dividing, I am just going to go ahead and multiply by the reciprocal of the second fraction. So I would have 3 over 7 times 14 over 9. Then I would do the same process that I did for multiplying. I would simplify. These are both divisible by 7, so 2 and 1. These are both divisible by 3, so 1 and 3. 1 times 2 is 2. 1 times 3 is 3. So that one simplifies to 2/3. Okay, so we're going to be simplifying rational expressions. So what I would recommend is these following steps. Factor everything you can, then simplify or cancel things out. Then perform the operation, so whether it's multiplying, dividing, adding, or subtracting, and then factor or simplify again if you can. Okay, so let's look at example 1. Okay, I look at this one. Biggest thing to notice is these are all monomials. Okay, there's only one piece. There's no adding or subtracting in between. So this is one piece, this is one piece. Okay, so since they are monomials, I don't need to factor. Okay, so there's no factoring necessary here. What I would do is just start looking at it. I like to look at the numbers, and I would say 15 and 5, both divisible by 5, which gives me 3 and 1. Then I have 4 and 16, both divisible by 4, so that leaves me with that. Then I would go ahead and just multiply across with my variables. I feel like it's the easiest way not to make a mistake. So I'd have 1 times 3 is 3. Then I have a times b squared, so ab squared all over 1 times 4, that's a 4. So I would have 4, and then I would write it in order, a to the third b. Now I go back to my rules of exponents. Okay, to simplify, I would bring my smaller to my larger exponent and subtract. So I'm still going to have 3 over 4, and then I would say this is a to the first, this is a to the third. So 3 is bigger. 3 minus 1 is 2, so I have a squared. Then I would move on to my b's. I have b to the first, b to the second. B to the second is larger. Bring 1 to the 2 and subtract. 2 minus 1 is 1. So I would write it We usually don't write that, so I'd have 3b over 4a squared. And that would be my answer for example 1. Example 2 then. It's a little bit more difficult, okay? And it's not really that much more difficult, but it's just a little bit. Biggest thing to remember is it is dividing, or notice that it is dividing, okay? What did we say to do if it's division? We would flip this and then multiply. So I'm going to rewrite this fraction, so it's 4x squared y over 15a to the third b to the third times 5ab to the third over 2xy squared. So whenever it's division, you just flip it and multiply. Then let's simplify. Looking at my numbers, okay, I have 5 and 15, which is 1 and 3. They're both divisible by 5. 2 and 4, 1 and 2, both divisible by 2. So now I'm going to rewrite it. 2 times 1 is 2, and then I'm just going to write them in alphabetical order. So I would have a b to the third x squared y over 3 times 1, so 3. Then I would have a to the third b to the third x y squared. Now I simplify by bringing smaller to the larger and subtracting. Okay, the thing I would notice right away is look at my b's. They're exactly the same, so they cancel. So this is a to the first, so I'm going to bring it here, so it's going to be in the denominator. 3 minus 1 is 2. My x's going to be in the numerator because 2 is bigger. 2 minus 1 is 1. And my y's, biggest one's in the denominator. 2 minus 1 is 1, so just y. So my final answer is 2x over 3a squared y. Number 3. Once again, I still notice it's multiplication, and these are all monomials, so I can just start simplifying. 8 and 12, both divisible by 4. 8 divided by 4 is 2, 12 divided by 4 is 3. 15 and 5, both divisible by 5, so 3 and 1. Okay. We could multiply and then simplify, but I could also notice the 3's. They're going to cancel. So some people forget, but you can cancel them if they're on the same side. Okay, so this is 1 and this is 1. So 2 times 1 is 2. 1 times 1 is 1. So I'm just going to leave it written like this. No 1 because you don't need to. And then I would have m squared and then n times n. So that's n squared r. And let's combine our denominator. I would have m to the third n squared r squared. Notice my n's are the same, so they would cancel out. Then I'm left with 2 in the numerator. The m's, bigger ones in the denominator, so 3 minus 2 is 1. And then r, bring it to the denominator, 2 minus 1 is 1. So my final answer is 2 over mr. I'm just going to write it a little bit nicer. And there it is. That is example 3. Example 4. Okay, I have a little stop sign, makes you look. It's division. Okay, so we have to divide, so it means we multiply by the reciprocal. The other thing I noticed, once again, monomials. No addition or subtraction with each individual part. So I do not have to do any factoring. So I'm rewriting the first fraction times the reciprocal, so flip it. 10xy over 9b. Okay, now I'm going to break it down. Okay, 18 and 9, both divisible by 9. 10 and 25, both divisible by 5. Okay, then I don't see anything else that will cancel. So 2 times 2 is 4. Then I would have ab squared xy all over 5 times 1, so 5. And then there's no a's, so b x squared y to the third. Okay, I just double check. 5 over 4 is reduced all the way. So I will have still 5 over 4. The a, there's no other a, so I'm just going to have an a in the numerator. B squared and b to the first. So it's going to be in the numerator. 2 minus 1 is 1, so b. This is x to the first, x squared. Bring it down, so I would just have x. And then I have y to the first, y to the third, bigger ones in the bottom. 3 minus 1 is 2. Okay, so my final answer, 4ab over 5xy squared. Biggest thing to check when you are done. Are all my a's, is there only one a written? Is there only one b? You shouldn't have a's and b's in the numerator and the denominator. Okay. So number 5 is a multiplication. And number 6 is a division. I would like for you to pause the video right now and try them on your own. and then come back. Okay. So hopefully you've had a second to pause the video and try 5 and 6 on their own. I'm going to go ahead and do number 5 right now. My 9 and 27 both divisible by 9, so I would have 1 and 3. These are both divisible by 8. Okay, so I would have a squared b m squared n to the third all over 2 times 3, so 6 a b to the fourth m to the fifth n. Then I would look at my a's. I have a squared and a to the first, so I'm going to have just a because 2 minus 1. B to the first and b to the fourth. So I still have 6 in the denominator. Okay. Bring the 1 to the 4, so 4 minus 1 is 3, so b to the third. The m, bigger m's in the denominator. 5 minus 2 is 3. Bigger n is in the numerator. 3 minus 1 is 2, so n squared. So a n squared divided by 6, b to the third, m to the third is my final answer for 5. Number 6, division. So I'm going to rewrite it with the flip. So I have 14 pq squared over 15 w to the 7th z to the third times 35 w to the third z to the 8th all over 21 p to the third q. Okay, so start simplifying. I look 14 and 21 both divisible by 7, so that would give me 2 and 3. These two are both divisible by 5, so 7 and 3. From that point, I'm going to multiply across. I would have 14, then I'm going to have pq squared, w to the third, z to the 8th, all over 3 times 3 is 9, p to the third, q, w to the 7th, z to the third. Now I need to simplify. 14 and 9. Only thing they are both divisible by is 1, so it's going to stay 14 over 9. P to the first and p to the third, so it's going to be p squared in the denominator. Q squared and q to the first, so it's going to be q in the numerator. W. 7's in the bottom, so I'm going to take 7 minus 3, which gives me w to the fourth. And my z. Z to the 8th is the bigger one, so 8 minus 3 is 5. So we have 14q z to the 5th over 9p squared w to the 4th. And that's my final answer for number 6. Okay. If you would like to take a break, now is a great time to take a break. We're going to be switching gears. If you notice, our step 1 is to factor everything you can. Well, we didn't need to factor anything with these pieces. Now we're going to have to do factoring. Okay. So that brings us to our review of factoring. Okay. What you need to remember is our quadratic is ax squared plus bx plus c. And you are trying to remember or find out what multiplies to c but adds to b. And you put those values in here. Okay. So this is a trinomial. Notice how it says tri. There's 3 parts. So I put x in the front. I say what multiplies to negative 12 but adds to negative 4. Okay, well, what multiplies to 12? 1 times 12. Does that add to 4? No. 2 times 6. Could that add to negative 4? Possibly, if 6 was negative. So would that work? 2 times negative 6, that's negative 12. 2 minus 6 is negative 4. So there is my trinomial factored. Moving on to 8. Okay, now I want to multiply to this, and we want to add to 3. 2 is nice. There's only 2 things that multiply to 2. 2 times 1. Do they add to 3? Yes, they do. Both got to be positive. So there's my answer for number 8. All right, number 9, we get a little stop mark by it. It's different. It's not a trinomial, it's a binomial. So I'm going to just look at it and see what can I take out of both of them. 4 and 12 are both divisible by 4. And they're both divisible by x squared. So I'm going to GCF, greatest common factor, factor this one. So I would take out a 4x squared. So I mean, what do I have here? X. When I multiply, I'll get back to 4x to the third. Plus 4 times 3 would give you 12x squared. So there is number 9 factored. Okay. That's our quick little review of factoring. Now we're going to simplify rational expressions using factoring. So example 10, we were looking at all of the examples earlier and saying, okay, they were all monomials. There was no adding or subtracting on them. However, we look at 10 and I see, well, now there's adding and subtracting. That's the big key that I know I need to factor. Okay, so number 10, I look at the first one. I'm going to put 2 sets of parentheses with my x. And I would say what multiplies to -8 but adds to 2. Okay, well, 4 and 2 would work. I would have to have +4, -2. Okay, moving on to my denominator. What multiplies to 3 but adds to 4? Well, 3, there's only one thing that multiplies 3, 1 times 3. And would they add to 4? If they're both positive, yes, they were. Times, now look at this one. It's a binomial, so it's like our example 9. So I can say, okay, I can't factor it in this way, but what can I take out of both of them? A 3. Don't forget it's x plus 1, because if I redistribute, I need to get back to that, over x minus 2. Now I go ahead and I say, can I cancel anything or simplify anything? There's an x minus 2 on the top and on the bottom. As long as there's one in the top and the bottom, they can cancel. Okay, same with my x plus 1. Looks like that is it. So I would have 3 times x plus 4 all over x plus 3. And I would just confirm none of those cancel. And you could leave it like this, or you could redistribute the 3. I'll take either answer. And there is your answer for number 10. Number 11 gives us a little stop mark. The reason is, you gotta flip it. It's division, so we flip. Okay, so the first fraction stays the same. Then we multiply by the reciprocal. What I need to do now is factor. These two pieces don't need to be factored. They're already simplified as far as they can. This piece right here is our difference of perfect squares. Remember, difference means that it's subtracting, which we have, and then what's the square root of 9? 3. So remember, we have x plus 3 and x minus 3. That did not write as a minus. X minus 3. All over. Now, this one's our trinomial, so I say what multiplies to -12 but adds to 1. 1 times 12 won't work. 2 times 6 won't work. 3 times 4, that could work. Plus 4 minus 3, that would give me 1, and when I multiply, I get 12. Then I cancel. Like I said, as long as there's 1 in the numerator and 1 in the denominator, they cancel. So x plus 3, x minus 3, these are not the same. So my final answer is x plus 2 over x plus 4. One thing I will say, some people are like, oh, these x's, they can cancel. Not true. Do not do that. You will get it wrong. It's addition, so it has to be this whole piece. If it was multiplication, that would work. However, it's addition, so you can't do that. Example 12. It's multiplication, so you can just factor it as is. Y minus 1 is factored all the way. This I can factor a 5 out, so I would have y plus 5 times 3 gives you 15. Now, on the numerator, I say what multiplies to 6 but adds to 5. 1 times 6, would that work? 1 would have to be negative, so that's not going to work. Okay. 2 times 3, that would work. So plus 2, plus 3. And I move on to the bottom. What multiplies to a -5 but adds to 4? Well, the only thing that multiplies to 5 is 5 and 1. If I want to add to a +4, it means this is positive and this is negative. So there is that. Now I just say what can cancel. Well, there's an y minus 1 on the top and the bottom, y plus 3 on the top and the bottom. And I look, there's nothing else that will cancel, so I would have y plus 2 over 5, y plus 5. And like I said before, I will take this, or if you want to redistribute the 5, that will work as well. Okay, that is example 12. Example 13. Should have a little stop mark by it. It doesn't. We're getting good enough and trained well enough to see that it's division, so we need to multiply by the reciprocal. Okay, I don't want to have to rewrite this a few times though, so I'm going to factor the first one right away. What multiplies to negative 35 but adds to 2? Well, right away 35, I think 7 and 5. So this would have to be positive, this would have to be negative, over difference of perfect squares, so x plus 2, x minus 2, times the reciprocal. And these two are already factored down. Now I can go ahead and cancel. X plus 2's, x minus 5's, and all I have is x plus 7 and x minus 2. There is my answer, simplified all the way for number 13. Okay, we only have one more type of problem to do. That is that complex fraction that I talked about. Okay, a complex fraction is a fraction inside of a fraction. Okay, so multiply by the reciprocal of the denominator. So the way you handle this is you just leave the numerator the same and you multiply by the reciprocal of this. So it's x over 3 times reciprocal x squared plus 1 over x. The reason that you do it that way is because if I multiply by the reciprocal here and up here, okay, the same thing over the same thing is the number 1, which you can multiply anything by and it stays the same. And these would cancel with each other and you're left with 1. So that's why it simplifies to multiplying by the reciprocal. So that's what you need to remember. You can just think about it as division, which a fraction really represents. So 14, we have a rational expression essentially being divided by another rational expression. So we're going to multiply by the reciprocal. So this is x squared over x squared minus 25y squared times the reciprocal. Flip it, x over y squared over x. Now what we need to do is, this is a monomial, so these are good, but this is a binomial and it looks like it can be factored. So we're going to factor, so I would have x squared over, okay, this one's a little tricky. Difference and the square root of 25 is perfect and the square root of y squared is perfect. So it's a difference of perfect squares. We have x in the front. Square root of 25 is 5. Square root of y squared is y. Then we would always have a plus and minus times x minus 5y over x. Okay, the x minus 5y's will cancel. I will have x times x plus 5y in my denominator and x squared. Now, this is where it can sometimes get confusing if you're not careful. Okay, this is a monomial and this is a monomial being multiplied. And since they're being multiplied, it's fine to simplify, just like the very beginning problem. So this is a 2 and this is a 1. So you'd bring the smaller to the larger and subtract. So we would really just have x over x plus 5y. The reason that's okay is there is multiplication here. Okay. Now looking at this, you can't just cancel these x's because it's addition. So make sure you're careful. It has to be being multiplied in order to cancel top and bottom. Okay. So there is example 14. Example 15. Okay, it's a complex fraction, so we're going to have to multiply by the reciprocal. I'm going to rewrite this. I'm going to rewrite, though, if it's squared, I can write it twice. It's really x plus 3 times x plus 3 over x squared minus 16. That's a difference of perfect squares. Square root of 16 is 4. So plus 4 minus 4 and times the reciprocal. So x plus 4 over x plus 3. And now it's back to what we were doing earlier and cancel. Notice you can only cancel a pair, one in the top, one in the bottom. Can't cancel out this one as well just because there's an x plus 3 in the bottom. Only one. So I'm left with x plus 3 over x minus 4. And that's my answer for number 15. All right, last one. We love geometry almost as much as we love factoring. Okay, a parallelogram with an area of 6x squared minus 7x minus 5 square inches has a base of 3x minus 5 inches. Determine the height of a parallelogram. Okay, first thing we need to remember is what is the area of a parallelogram? Area is equal to the base times the height. So we are trying to find the height. So I'm just going to use this equation. To find the height, you'd have to take the area and divide it by the base. Oop. So we're going to find my height, and it's my area, which is 6x squared minus 7x minus 5, divided by the base, which is 3x minus 5. We just got done simplifying rational expressions, which this is. So now I need to factor my numerator. This one is a little bit more complicated because my a is not 1. So we need to think to ourselves, okay, guess and check. I like to start with factors of 6 that are closer together. So let's start with 2 and 3. Now I would say, well, what multiplies to 5? Which is nice because 5 is a palindrome. So 1 times 5. Okay, so let's just recap really quickly here. In order to get 6x squared, you'd have to take 2x times 3x, which is 6x squared, so that works out well. And 1 times 5 gives me 5. Now, the way you get your negative 7 is by checking. This gives me 3x, and when I multiply this, I get 10x. With 10x and 3x, could I get to negative 7x? Yes, I could. So I would make my 10 negative, and I would add 3. So that means when I multiply these, this is negative, and this is positive. Okay, all over my 3x minus 5. I'm going to rewrite it one more time just to make sure it's clear. So I would have 2x plus 1 over 3x minus 5 all over 3x minus 5. And here's my other little hint with area or geometry problems like this. Look at what the denominator is. Chances are you want to be able to cancel it. So you could try right away, well, I know I have to have a 3x, so I mean I knew I had to have 2x. Okay, and go from there. And I look at this, these cancel, so my height is 2x plus 1, and this would be, it says square inches, so my height is 2x plus 1 inches. Okay, that will do it for Unit 9, Video 1. If you have any questions, please come and ask me. Otherwise, have a great day and take care.